Hello, everyone. This is Uzair from the NCache team. And with me today, I have our Senior Solutions Architect, Ron Hussein. Welcome to our webinar. Today's webinar topic is going to be WAN replication for a multi-data center deployment using NCache. In today's webinar, we're going to cover NCache's bridge feature, which also includes NCache's bridge topology, the advanced bridge features NCache has, queuing multi-site sessions, as well as bridge performance and debugging monitoring options. Now, at any time during the webinar, feel free to use the questions tab to type in any questions that you may have, and Ron and I will answer it to the best of our ability. And before we get started, as always, we hope that everyone is taking great care of their health during these unprecedented times and staying safe. Okay, without further ado, Ron, take it away.
Very good. Thank you, Zach. Hi, everybody. My name is Ron, and I will be your presenter for today's webinar. And as Zach has mentioned, today we have lined up a very important topic, specifically for applications which are deployed in multiple data centers. These could be for various reasons. For example, you need a DR site, you need active-active multi-data center deployment, or it could be east to west migration of data that you need. So we have a WAN replication feature available with the help of our bridge topology, and I'll cover all the details how to use object caching while you have WAN replication turned on, use it for active passive, active and multiple active data center deployments. So we have a lot to cover. I believe everybody can see my screen and hear me fine. If I can get quick confirmations through GoToMeeting questions and answer tab, that would be really good, and we'll quickly get started with the presentation. So please confirm if everybody can see our screen and hear us fine without any issues.
Looks good, Ron.
Very good. So I'll get started with the very basic information about why you need a distributed caching system like NCache. So typically, it is the application, performance and scalability bottleneck that allows the issue that limits your applications to perform in a faster and more reliable manner. Your application tier is very scalable. You can have a web application or a backend application. You can always create a web form or application server form where your application can be deployed on multiple servers. Your load can be distributed. Multiple servers help serve all those application requests in parallel, in combination to one another. But all of these applications need to talk to a backend database, and that is usually a source of contention. Database becomes a performance as well as scalability bottleneck for your application because you cannot scale out data based servers, and it's very expensive resource as well. So you can always scale up, but there's a limit to it, how much you can scale up a database server. NoSQL is usually not the answer for it because you need to re-architecture your application. You need to stop using a relational database and start using a NoSQL data source in order to use that. And we also have a product called NosDB, which is a NoSQL database, but we're projecting a different way to handle this, and that is through distributed caching system. So first of all, solution to this scalability problem is very simple, that you start using an in-memory distributed caching system. It's super fast because it's in memory in comparison to disk. So your performance of your application is going to be improved right away as soon as you plug in NCache. Secondly, it's a team of servers. It's a cache cluster. It's not just a single source like database. You have multiple servers joined in a cache cluster. So it's a logical storage, which is pooled by many servers that you can choose to add. That makes it very scalable in comparison to your relational databases. You can start off with 2 servers and you can add more servers at runtime. So it makes it more and more scalable, and as a matter of fact, linearly scalable, where you can add more servers, and as a result, you keep increasing your request handling capacity out of NCache. Nice thing about NCache is that you use it in addition to a backend database, a relational database. There are a lot of features which complement your use of data that comes from a backend database. So you can always use NCache in conjunction with your relational database. It's not a replacement of your relational data sources. Some scalability numbers. NCache is very scalable. As you add more servers, NCache allows you to handle more and more requests out of NCache cluster. We recently conducted these tests in our QA environment. We use our AWS lab, where we kept on increasing load and also kept on adding more servers and up to 5 Ncache servers, which is a very regular configuration for our distributed cache. We were able to achieve 2 million requests per second, and that was an upward of increasing trend where whenever we added more servers, we added more capacity to the cache cluster. With an average 1 kilobyte object size, this is the kind of performance you can also expect out of Ncache. And with better hardware, you can even stretch these numbers and get better performance throughput out of Ncache. By the way, these benchmarks, there's a white paper and a video demonstration published on our website as well. So you can also take a look at that as well. Some deployment details. How would a typical deployment of Ncache is going to look like? Here is a single site deployment of Ncache. As you can see, we have a single site. And in your case, once we talk about the WAN replication aspect of it, obviously we would have more than one deployment. We would have a separate data center where we would also have Ncache and applications deployed. So with our distributed cache deployment, as shown in the diagram, let's talk about how a typical deployment looks like. So we have a team of servers again. We have 4 to 5 servers showing in the diagram. That is where your cache cluster is hosted. And as you can see, it sits in between your application and database. The idea here is that you use these sources in combination to one another for object caching, but for session caching, cache becomes your main source of data. So all your sessions can be stored in Ncache, and you don't have to go anywhere else. Very flexible deployment model is available. Ncache can be hosted on premise. It could be physical or virtual boxes. It could also be in cloud. It could be public or private cloud. It could also be on Azure AWS, because we have marketplace images available for both of these cloud vendors. But in general, any server which has Windows or Linux, and you only prereq for Ncache is .NET or .NET Core framework. So these are requirements. It's just .NET and .NET Core which Ncache needs as a prereq. If that is available, Ncache is very flexible to be deployed on Windows as well as on Linux environments. And like I said, it could be any environment as well. It could be, you can use Docker, and you can also host Ncache in Kubernetes cluster, and that opens up a lot of other platforms. You can use it in OpenShift, you can use it in Azure Kubernetes service, Elasti, Elastic Kubernetes service as well. So all those platforms are equipped. Ncache is equipped to be deployed on all those platforms. There are 2 deployment options. One is that you go with a dedicated cache tier as shown in the diagram, and the second one is and in dedicated, your applications run on separate boxes, and Ncache runs on a separate dedicated tier. We also have a shared tier approach available as well, where you can also run Ncache alongside your application boxes. So wherever your applications are hosted, Ncache can be hosted on top of it. So I believe this is pretty straightforward. In a multi-data center deployment, you would have more than one data centers, and you would have same deployment for Ncache on the other data center as well, which we'll cover in upcoming slides. And by the way, if there are any questions, please, you can always post that question in our questions and answer tab, and Zach and I will keep an eye out for all those questions which are going to be posted, and we'll be very happy to answer all those questions for you. Excuse me.
Speaking of questions, since you mentioned it just now, I have one that I'd like to bring out. Well, it was very simple. You were mentioning Kubernetes now. So the question was, when you're going to talk about bridges and this in general, are there any operating system requirements for all of this? Are you able to run this on Linux?
Absolutely. Ncache is very flexible. As you can see, even on our deployment diagram, you can see Ncache is supported on Windows and Linux servers. So on Linux servers, you just need .NET Core release of Ncache, and we have a server as well as client release. So if you want to run Ncache servers on .NET on Linux using .NET Core, that's possible, and then your applications can always use our .NET Core release and be deployed on Windows as well as on Linux. So yes.
Awesome. I'll let you actually go through the rest of it, and I'll bring up the questions later.
Very good. So next we'll talk about multi-data center deployment of Ncache. Now, if your application is deployed on multiple data centers, or it could be that you have one active site and then we have a passive site for DR scenarios. For example, the active site goes down and your application requires that you should be always up and running. If it's a mission critical application, it's important to your business. Having a downtime on a site level is something that would impact your business. Ncache cluster is designed in such a way that it's already equipped with high availability and data reliability features. So on a single site level, if one or two servers go down, for example, if you lose a server, Ncache is equipped to handle that outage without any issues. But today we're talking about if we what happens if we get a site level outage, or we need to bring site down for maintenance, entire site being down, so all the servers are down. Ncache is even equipped to handle that scenario, and that's what we're planning to cover today. So let's talk about why do we need WAN replication. Typically, when your applications need high availability, single site can become a single point of failure. If your site goes down, you lose all the data and you can potentially get downtime on your application users, and that could impact your business. We've already established that. Multi-region apps are slow if they have to talk to one another across WAN. For example, you have one data center deployed, your application deployed in one data center, which is in US region, and then you have another application which is deployed in a Europe or any other, for example, Asian region. So in that case, if your application databases are located on one of the data centers, the remote site has to go across network. So your network speed won't impact the latency for that other site. In order to handle that scenario, you usually replicate your data sources across WAN as well, and that's what we're recommending for Ncache as well. That Ncache should be replicated. But considering that you have a common data source, the remote site has to go across WAN, and that could potentially give you a performance impact because data is not local for that site. Distance between data centers would also impact your throughput. There is only so much of data that you can transmit between sites. So that can limit your capacity of request handling. So these are two issues if you have multi-regional apps and if both apps are active. Data replication at request level is expensive as well. For example, you don't replicate entire database and you have data source sitting on one data center. Now a request which goes on a remote location, a geographical location which is remote to your database, a request level replication for every data request unit which comes to a data source, that's going to be extremely expensive, and that would eat up a lot of bandwidth and resources. So you need an active mechanism where you have data locally available, and that's why you need WAN replication of cache needed as a must, so that your data from one data center is replicated across network to the other side. Some use cases, why where exactly you can use WAN replication. The most common one that we come across is disaster recovery site. You have an active site that is serving your main business use case. That's where your traffic is being generated and being handled. What if the entire site goes down? You need a fallback option, right? So that DR site should have data made available already. Otherwise, it would not have that data requirements handled if it has to go back to the site which is already down, right? So you need data to be made available on the DR site so that it's already up and running. You just need to shift your traffic to that DR site. You should not do anything else, just route your traffic to the disaster recovery site, and it should work with the same performance value, same performance matrices that you had with the active site. So 100% data recovery in case of failure is possible with the help of Ncache WAN replication. Multi-regional applications can share data as well as load. Now, with active sites, if you have one region in US and one in another part of the world, for example, Europe or Asia, uh, if you want that the request from a data center should be handled based on the location affinity, you can achieve that. Now, user from Asia could connect to a site within that region, nearest to that region, and they can use the cache over there as well. And that cache is in sync with the other cache, which is in US region. So any user which bounces off, for example, you need to manage overflow, or you need to distribute capacity. Some of the users need to bounce to US region because Asia region is fully choked. So you can always do that. So on a site level, you can load balance your request based on the capacity that site is handling at that time and at that point in time. Since cache data is already replicated across data centers, and we'll talk about how to achieve that. So your multi-regional applications are efficiently able to share their application data and also share the request load, and they can have equal load sharing as well. No redundant data migration is done. It's just based on the request bouncing from one data center to the other, and you can always get that data from the cache which is already connected there. East to west application data migration is another use case. For example, Asian markets start earlier than the Western markets, right? So your data trend usually follows from east to west. So your eastern site can have our cache set up, and with time zone, data moves between data center to the western region and it reaches to the west. So if you have data replicated across data centers, the cache data, the western region would be able to take advantage of all the data that is made available from the eastern region. So you can have east to west data migration made available. And the maintenance use case is the third one, where a fourth one, where we can deploy, upgrade, and maintain without any downtime. That's becoming a very pressing use case with NCache as well. That if you're planning to upgrade, you can have upgrades between older and newer versions using our bridge topology, where older data version data can be transmitted to the newer version with live upgrades feature. It could be between sites. For example, you can use one site and replicate data actively to the passive site, and you can upgrade, deploy new code, maintain perform maintenance on the active site, and you have all the data made available, and your traffic can be routed to the passive site for that matter. So both sites can always be up and running without zero downtime and any application data loss. So let's talk about how to handle that. The name of the feature is NCache Bridge. It's part of the same product. You don't need any separate installation for it. NCache Enterprise is equipped with NCache Bridge topology, and let's talk about it. Any questions, Uzair? Zach, are there any questions?
Actually, no, not at this time. I mean, there are some that are going to come in, I bet, but not at this time, no.
Very good. Right. So our NCache Bridge feature allows you to replicate cache across data centers. It's based on async replication model. It does not incur any performance degradation on the application side. Your cache applications are connected in active, to the cache on one data center. For example, you have clients here, and then you can create a bridge, which is also an active passive queue, and that would transmit data to the other sites asynchronously. So it's based on async replication, so there's no performance degradation in replication of data. It's very reliable, it's fault tolerant, it automatically detects connection failures, it automatically reconnects, there are automatic retry options available. So, and bridge is also backed up on active passive queue. So there is an active bridge server and then there's a passive bridge server as well. If active bridge server goes down, the passive would pick up and start all the replication operations without any delays. It's very easy to set up. You don't need any code changes, you don't need any extra installations. It's part of the same product, the enterprise, and it gives its own monitoring and management support, which is integrated into the same NCache enterprise product. And it supports multiple topologies, which I'm going to cover next. So we have three major topologies. We have active passive, where we have an active site, and then we have passive site. Passive site is also taking client requests, but the data flow is from active to passive. So if you have DR site requirements, you can use one site to be active, connected to bridge, and then you can have other site passive. The active site transmits data to the passive site. So it's a one-way transmission. The term passive essentially means that passive site is not transmitting data back to active. It is still running, and you have client applications take advantage of it. So it's not something which is stopped by any means. East to west migration can be achieved with active passive. Your maintenance and upgrade use case can be handled with the help of active passive. The active topology is when you have one application deployed on two different geographic locations, and you want data from site 1 to be made available on site 2, and site two's data made available on site 1. If your application needs data sharing requirements between geographical sites, you can target active where you have users active on both data centers. Clients are connected to both data centers, and there's a two-way replication going on between two different sites. And then we have two plus or three plus active topology, where we have one primary bridge server, but it's transmitting data to all sites, and those sites are also transmitting data back to every other site. So one update has to be applied on all of the data centers, and vice versa. So here is our active passive. In this, we have bridge, which is a queue, which is also active passive. We have cache cluster on site one, which is just handling client requests. We have three servers here. It's connected to bridge. Bridge also resides on one of the sites, or in some cases you can have active bridge on site one and passive bridge server on site two. That's also possible, but we typically recommend that you move bridge on one of the sites in your deployment architecture. The second site is passive site, and again, by passive, it's still running. It's just that the passive site does not replicate data back to the active. It's one-way transmission of data, and that's all it means when we say this is a passive site. You can essentially run client applications here, and it's fully functional even in this state. So it's a replication of data, active passive. So if this server goes down, the passive becomes activated and it's automatic. No code changes are needed. I'll show you how to configure bridge once we progress to our hands-on portion. So it's pretty simple.
A question came in,
Mhm.
and it has to do with this active passive. It's primarily if you have an active and a passive site, how do you make the passive site activated? Is it a manual process? Is the site stopped? How do you do that?
Okay, so if I've understood this question correctly, the passive side, in terms of how we activate it, it's already activated. It's running. And if we bring this side down, or we want to move traffic here, it's your application traffic load that you need to move to this site. So you have application servers here, you have application servers here. Whatever data that you have is going to be transmitted here, and this site users can have the data made available from the cache itself. Now you can always route your traffic to the passive side, and you can get all the data made available. So there are no steps needed in order to make it activated. However, if you want this side to start transmitting data back to the active side as well, you can make it active by using our GUI tools. So in terms of replication, if you want this to be replicating data back to the active, so you can always make this active, and this is a runtime process. So you can just, with one line of with one click in the GUI tool, you can achieve that, or you can use our PowerShell tool to make that happen. But if your question is in regards to making the passive node active, if there is a manual step in order to have client applications connect to it and be able to use data, it's already running. Your applications start using it by if you start routing traffic to this cache cluster. So within your load balancer, you switch this site off and route all your traffic to the available site, which is up and running already, and you can get take advantage of all the data which is being replicated.
Okay, awesome.
Very good. So active, it's again based on same principle, where we have bridge running on one of the sites. We have cache 1, cache 2. Both sites are active. And even the passive topology can be turned into active by right clicking and making it active. And in this case, data from site 1 cache is transmitted to site 2 asynchronously, from cache to bridge and from bridge to cache. And then similarly, site 2 is also transferring data back to site 1. And 3 plus active data centers, where we have 3 or plus active, where we have one of the sites as bridge server. We can also have a fallback site for bridge. We can have a backup bridge site as well. But in general, we would have one of the sites which would be hosting bridge, and then that site is transmitting data to other sites. And similarly, site 2 is transferring data to site 1 through bridge and to site 3. And for active, we have conflict resolution, which is time based. So last update wins. All the data structures that we use are conflict free. These are conflict free data types. There are no race conditions or any data consistency issues, because last update is going to be applied on the cache cluster across the board. So NCache manages, if there are 2 updates for the same key come in, NCache would evaluate that and would also allow you to build your own conflict resolution if that's a requirement. So it's managed as part of NCache topologies. So here's a quick peek into our bridge configurations. We have NCache Bridge config. NCache Bridge is the name, and then we have London cache. environment 1, so that you can have multiple caches with the same name as well, New York cache, and these are connected. So let me actually show you all of this in action, how to configure a bridge, how to get started with it, and then we'll actually show you object caching and session caching applications.
Before you get into that, Ron, I had a question come up just on the previous slide with the code. And the question is, what are the code changes that are involved in order to set up the bridge? Do they need to write any code in order to have the data replicated through the bridge?
Not at all. We don't need any code. It's just a configuration. So you have cache 1 on data center 1 and cache 2 on data center 2. You simply configure a bridge, and whatever data that's already being added by your applications into NCache is going to be replicated through bridge automatically. So it's bridge's responsibility to take charge of all the replication. You don't need to write any code explicitly to have data replicated across data centers. And when we say the data types, the conflict resolution, that is something which is also implemented by default, which is time based. But if you want to implement your own conflict resolution, if your business requirements are that you evaluate objects in case multiple updates come in that case you can implement that interface. But as far as replication of data is concerned, it's bridge's responsibility. You don't have to write any code for that.
Okay, great. Awesome.
Very good. So let me quickly get started. I'm going to create a cache. Let's say I'm going to name site 1 cache. Or let me actually use this right here, site 1 cache. This is just to give you an idea how to quickly get started and be able to create the bridge. I'll keep everything default because NCache architecture covers all these details. So I'm going to quickly go through them. Partition of replica cache, any cluster topology, async replication. I'm going to choose 101, and let's see if I can pick 102 if that's available. These are my 2 servers to host the bridge. I'll keep all of this default, start this and auto start as well, finish. So my cache 1 is on 101 and 102, which is going to be created. Let's see how it goes. And then I'll go ahead and create another cache, which would be on separate set of servers. And then I'll host the bridge and show you how this would all work out. Right, so we have site 1 cache fully configured. As you can see, it started as well. Let me bring this down right here. Now I'm going to go ahead and create, actually, I'm going to create another cache, which is site 2 cache. I think I can use that. I was playing around with it earlier on. Keep everything simple. And this time I'm going to give separate set of servers so that we represent this as a separate site altogether. Keep everything default. And by the way, our bridge allows you to have remote management of all sites. From the management and monitoring tools allow you to actually manage all the sites along with bridge from one central location. So if you have network access, if there's a WAN link available between your site 1 and site 2, you can essentially manage everything. So we have site 2 cache right here, site 1 cache right here, 101, 102 representing site 1 cache, 107 and 108 representing site 2 cache. Now, and these are started as well. If I click on statistics, you can see there are no objects added here as yet. Data is not added in site 1 cache or site 2 cache. So we're good. I would simply run this. I think I have permissions issue to review this counter. I think I can. Okay. So you can see there are no items available as yet. I'm now going to link these 2 caches with the help of a bridge, which I will configure next. So I will just say NCache demo bridge. You can come up with any name. And bridge can be on any servers. For example, on 107. Let me just give my box. There you go. So let me just create bridge on 101 and 102. Actually, I have permissions issues, so let me just see if I can add 107. Otherwise, I'll just use one server for the bridge. Bridge requires certain ports to be opened, so I think my machine has all those ports open. So let me just use 101 for now. One server is good enough. The backup server is not there, but we can always add it. And I'll keep everything default and choose finish. Auto start the bridge when it starts up, that's also a possibility. And then if I click on view details on the bridge, for example, if I click right here, that would open all the bridge settings that we have. Here you can add more nodes to the bridge if needed, and you can also add more caches, which would act as active or passive. So if I click on add, for some reason it's not letting me actually add. Please bear with me.
I can sneak in a question while we wait.
Sure. Please go ahead.
Sure. Yeah, one just came up. It's a pretty straightforward one. It's has to do with how do you ensure secure data transmission?
We have encryption features available. So if you have cache level encryption or security turned on, bridge will obey that. So whatever being transmitted between cache 1 and cache 2 is going to be encrypted if you have encryption and security turned on. So we have AES, DES, FIPS compliant encryption providers as well. We have TLS 1.2 supported as well. So we have transport level security as well as payload level security encryption features. So you can take advantage of those features. All right, so I'm going to select one of the caches, site 1 cache right here. Right, so I can choose it to be active or passive. I'm going to go with active and choose finish. So site 1 cache is added under the bridge. Now I'm going to add the second cache, which is from 107 box. I hope that I'm able to open the service control manager. I am. Select it. Site 2 cache, let's make it again active. If you choose passive, it's going to be site 1 to site 2 cache, but if you choose active, it's between site 1 to site 2 and site 2 to site 1 replication of data. Let's choose finish. So whatever and then you can also review bridge counters. For example, if I come right here and open statistics of bridge from here, I can always see the counters of the bridge as well. Let me actually start this first. For some reason, it's the system is not very responsive, so please bear with me. And let me open the statistics window. So here's our bridge. Nothing is being replicated as yet because we don't have any load at all. So I'm just going to simulate some load by running a stress test tool. Site 1 cache. And since we have counters available, so we would have our client connected and would start simulating. Although we've run this only for site 1 cache, as soon as it connects, so please bear with me. So let me actually open monitor to review if it's indeed being connected to the cache or not. I think it is. So bridge has some activity, so which suggests that bridge is now taking requests. Environment is a little sluggish today. I apologize for that, but let's review how it goes. Okay, so since bridge is showing activity, bridge cache size is growing, operations received and then received per second are showing activity. So that essentially means that it's replicating data across sites. There you go. So we have site 1 cache right here. And if we go open let me actually log into our demo environment so that we see the correct view of counters from there. I think that should help us review any permission related issues as well, because it's taking awfully long time to actually load this. So, and I'm not able to see counter activity as well. All right, so let me launch this web manager here. There you go. So although it was not showing counters earlier on the local screen, but when I logged into site 2 cache from that server, the web manager is fully able to see all the counters. So we have count actively being replicated. I never ran any stresses tool on site 2 cache, but it's actively getting data here. Now, if I stop that, or even if I keep that running, I can now run a stresses tool for site 2 cache as well, and that will replicate data back to my site 1 cache as well. So that completes our testing. I think I should stick to having a remote in on this environment as well, so that we can see activities separately on both environments. So I'll just use site 1 cache from here, bridge from here, and site 2 cache from over there. Any questions so far? I'm going to cover some application related use cases next. So please let me know if there are any questions.
It's just a pretty basic question, but it was mostly just what environments do we support again? I know you mentioned a couple earlier, but I figured we could just list them all down.
Like I said, only prereq for NCache is .NET or .NET Core. You can use NCache on Windows and Linux environments wherever they are available. It could be on-premise, it could be cloud environment, it could be Azure, AWS, Google Cloud, or any other. It could be a hosted environment as well. It's available in Docker through Docker container, and you can use Docker images to host your cache and your applications. Kubernetes is also supported. OpenShift, Kubernetes service. I've mentioned Azure Kubernetes service, Elastic Kubernetes service. So wherever you can use Docker, you can use NCache over there. And it just boils down to one simple fact that if you have .NET Core or .NET installed, that's the only prereq for NCache. And NCache can essentially run on all those platforms, on all those servers.
Awesome, thank you.
Right. So let me actually run, although I'm using this bridge right here, I have another bridge which is available. So let me run another application, which is right here. It's a load balanced web application. We have designed it in such a way that we can route one request on one data center, and if that data center is down, the subsequent request would go to the other data center. So that would essentially give you a view of how to manage disaster recovery if you have NCache Bridge turned on and you get to have all your data made available. So first of all, I would run this from here, where we have, let me just open this from this window right here. So let me just get started with the object caching sample. Right, so let me just run this London cache sample. And then let me also open the other sample which is available. So I'm going to get started with Visual Studio, running the samples. So as soon as these samples would run, I would show you that you can essentially use object caching and route requests between data centers as needed. So that would give you a visual representation of data being added from one data center and retrieved from other, and vice versa through our bridge. All right, so this is using a London cache, which I have configured right here. If I show you real quick. So we have a London cache, and we have New York cache. So 2 caches representing 2 data centers, and then we have a bridge which is NCache Bridge. It has London cache as cache 1 active and cache as second. So I'm going to stop the bridge for now, show you these 2 caches separately, and then I'm going to simulate some data and show you how this works in the cache. So let it run, and as soon as it loads up, and this is using NYK cache, so let me just spin this up as well. Now that you know how to configure the bridge, so it's very simple in terms of connecting these 2 caches together by running the management tool on any box and be able to configure that bridge. So please bear with me. It would spin up some instances. It's awfully slow today. I apologize for that. So it's built event has been completed, so it would simulate that shortly. Right. So this is our main.aspx, and within this, I'm just loading some objects in the cache. That's all I'm doing. For example, within the right. So if I show you the main.aspx, it's actually loading some of the objects in the cache. So idea here is that we would hit London region site, and then we would hit New York region, and then I'll show you how to sync data added from London region to New York and vice versa. And a visual representation would make everything a lot more clear in comparison. There you go. So we have both sides up and running. We have, let me just open one right here and the other right here. Now, if I add, let's say 10 items, which it allows, 10 items are added. If I retrieve from the same cache, it's showing that this data is added from UK region, and UK customers are shown right here. Similarly, if I add data from the London, US portal, it adds 10 items, and then you see all those 10 items. But what if the user bounces and it needs data from both regions to be made available simultaneously? So that's not possible as yet. Let me just add 5 more items here so that this is different in terms of numbers. So we have about 15 items here and 10 items here. So with just one click away, if I just turn this bridge on, right, and open statistics, the first thing that bridge does is it actually replicates all the data that's already in the caches. So caches are already connected as soon as we started the bridge. We have bridge replicating 25 items. So that's exactly what we added. So if I open the counters of, let me open the London cache as well as New York cache and open statistics. For some reason, this is taking time, but eventually it will open. Now we have statistics right here. We have clients connected, and we have the count value showing right here. So it's showing about 25 items, and that's what you're seeing on the New York cache as well. Now coming back to my application, I would keep the same application running, but this time I would just fetch data from here, and I expect to see all the items in the cache. So all 25 items London as well as US items retrieved here, because bridge replicated data from cache 1 to cache 2 and cache 2 to cache 1. So 15 items here are now added with 10 more items to 25 items together. And if I fetch data from the cache, the US cache, I see all the items in the US region as well. So again, it's a two-way transmission. It could be more than two. It could be active passive, where one-way transmission can be done, or active active as shown in the sample application. Now any new item being added, let's say 20 more items added, let's say, and if you fetch from here, you get 45 items. And if I fetch those items from here, you would see 45 items here. So it's instantaneous. Any items here added here, let's say add data on the, that would increase the count from 45 to 68. But if I fetch data from here, I get same items made available from here. So see how fast it is in replicating data between different sites. So these two caches are, and these caches are also running on multiple servers as we speak. So that completes our object caching demonstration. Let me also show you how to handle this through, if you're using ASP.NET Sessions. In multi-sites, you can also have ASP.NET Sessions. So for example, if this is through a load balancer, I would just add some items. That's a separate application. We have two web servers, site 1 web server and site 2 web server hosting the same application across data centers. So I'll just add some items. So as soon as it adds, and let me actually stop the bridge one more time. If I view cart, so we have one item added. Let's say add some more items. Right. So we have some items made available. Now if I go to IAS, the London side, let me just actually start this as well. Right. Bring back here, view cart. I really hope that it hits London side as a priority. We don't have any items over there, so let's see where it ends up. And then we'll connect the bridge and show you that whatever data that you add from site 1 is made available on site 2 and vice versa. First request is usually slow. I just started the application. There you go. So if we caught here, we get 0 items returned. So these two sites are out of sync, although your user session is bouncing from one site to the other whenever we start or stop the site. Now I would simply turn on the bridge on the same lines as we've done earlier on. Right, so it would run and it's going to start. Again, I'm going to see statistics. So 69 items are there. These are from the previous test. But now if I come back to my site right here, right, let's start over. We've added some items. Let's keep doing that. Now, coincidentally, if this or if it goes down due to power failure, or you bring it down, if I bring London side down, the only site is the New York side is still up and running. So if I simply hit view cart, same data item are made available from the US portal, and it has data added from the UK side. So you can see data being bounced from one site to the other, and your user still gets the data back. Now, if even the site becomes back, comes back online, it would again be able to fetch all the session data from the cache. Similarly, we have multi-sites ASP.NET Sessions. That's a separate feature. So we recommend Bridge for your object caching scenarios where we have a lot of data transmission happening behind the scenes between two caches. And we've seen that for object caching as well as for session caching. But for session caching, we also have multi-sites ASP.NET Session caching use case as well. So if I don't use the bridge, I still can link these two sites together. And that is through a separate feature which is available. And for that, I would just stop the bridge. As soon as it stops, I'm going to come back here. Let me just clear contents so that we start over. And that's actually a better way of synchronizing your cache for session caching. Reasons for that: session is a very transactional data. So you don't want your session data being replicated, although your user is not bouncing from one side to the other, right? So if your user is mostly on one side, and because it's a human user having ASP.NET sessions, so in that case, it's a transactional data which is transient in nature. It would not be needed on the other side. It's only based on the user which is there. And if you end up changing, your user from one side to the other, that could be managed with on-demand replication of data. You don't need to replicate all session data. For example, overflow happens where one site is being more hitting more capacity than other, and you want overflow users to go to the other side, and they already had a session object created here. So you don't need all sessions there. You just need sessions of that particular user. So in order to cater for that scenario, we don't recommend that you turn on bridge. So for that, we have another feature called NCache multi-site session. So multi-region ASP.NET Session Store Provider allows you to actually achieve all of that without using bridge. So you have site 1 cache, which has sessions, and we have site 2 cache, and site 1 has primary cache address and the backup cache address across region. And similarly, site 2 cache has primary and backup concept. So if a user bounces from one side to other, your cache clients, which are your application service, would go to the other site on demand, and they would get the session data made available from there. And all it needs is information to other site cache. For example, we have primary cache and secondary cache, London, New York, and you can have multiple of backup caches. So in case London user bounces to New York site, it would go back to London cache and would fetch the data and keep it there. And in order to demonstrate that, I would again get started with a cache application. For example, I add some data here. Again, this is using London cache. Add items here. Remember, I've cleared the contents in the cache, so we don't have any items here. And similarly, let me just open the London cache statistics. So we don't have any items here until the first request comes in. Let's say add. So we have 2 items with the same name, of course. So one session is created here. It's not replicated on New York site as yet, but we have multi-site session feature enabled. We don't need bridge for this because we want on-demand session replication to be done. We've done these configurations where we have primary cache and secondary cache, and then we have session state provider plugged in. So it's just based on session store provider settings, NCache is able to handle multi-site session use case without using bridge. And it's on demand, so it's much more efficient as far as session data is concerned. So what I would do now is I would bounce the session request back to other site by going to IAS, and I would stop the London site completely. I would keep the cache up and running, of course. And if I now fetch this, first of all, it would get the data from the US site. Same items would be made available from there. And as soon as it completes, I would add some more item and bring the London cache back up online. So it's an on-demand replication, which I'm trying to demonstrate. So let's see how it goes. Let's say, let me add some items. There you go. So let me turn this site back online. Since it's sticky to the London site, so now that I've brought the US user back to London site, let's see how it goes. There you go. So same items are made available from the London side as well. And the data elements were added from the US region. If I add some more item here, I would be able to add those items here as well. Let me simulate this failure one more time by stopping this site, and let's see if it bounces to the other side as well. I think there's some configuration related issues previously, but now that this site is stopped, let me just view cart. I expect, there you go. So the same session is now made available from the US side. And remember, I don't have any bridge configured here for this feature. It's just the multi-site session. Bridge is stopped. It's still replicating data, but it's on demand. So that actually completes it. For object caching and less transactional data, reference data, and static data, we recommend that you turn on bridge and take advantage of active replication between data centers. But session is a transactional use case which has read and write request combination. So it's very heavy. While you're updating data from one data center to the other, data is already changed on the primary data center. And session user does not bounce from one data center to the other. It would be only on one site at any given point in time. So you don't need active data replication. You can have on-demand replication. When it bounces from region 1 to region 2, you should be able to get the session data from there. And if it bounces back to region 1, you should again be able to get the session data made available. And for that, we recommend that you use our multi-site session feature without bridge. That completes it. There are some advanced features which I would quickly discuss. Bridge is highly available. Failover support is built into it. Any bridge server going down will not incur any downtime. Bridge queue is very optimized. It's fast. Additionally, you can enable some queue optimization features, which would make it further optimum. Conflict resolution is built into it. Last update wins. But if you want to implement your own conflict resolution, so you can use a handler and register with NCache. So this interface can be called in case there is a conflict of two keys where two updates happen to occur at the same time. So NCache would give you control, and you can verify version of that item and take decision which one wins. Handling disaster at runtime. Zach initially asked how to make the passive site active. You just need to route traffic to the passive if active site ever goes down, and there is no downtime, and automatic resync happens if the active comes back up. In active traffic is routed to both sides. Any site going down would not have any impact. You just need to route traffic back to the active. And if the other active comes back online, the resyncing is done automatically. There is no delays, no manual intervention needed. In 2 plus or 3 or more active cases, if non-bridge active site goes down, you just need to use the traffic to any other site, and there would be no downtime or data loss. In case the bridge active site goes down, for example, if we have one bridge site right here, if this goes down, we have an option of backup bridge site as well. So you can turn that bridge site enabled. And for that, you can specify the backup bridge to pick up replication. So replication would stop if the entire bridge site goes down, but we have an option of backup bridge site as well. So I wanted to cover these aspects real quick. I think that should be enough for now. Any questions so far? Zach, you can pick it up from here.
Sure. I know we're running on the last minute or two here, so I'll just toss in one question that came in on what you revised just now. It had to do with conflict resolution. And I believe the question is, what are the examples of conflict resolution where we would need to implement it?
Okay. Typically, most of your conflict resolution would be handled by default, where you don't need to implement anything. The time-based conflict resolution is all what you need, with an expectation that you're running active sites and you need data from one data center to the other. You need updates from one data center to the other, so last update wins. But in case where data is more specific and you want to have value of the data, and that would determine what object should be kept in the bridge. For example, there is certain version or certain information or certain sequence number within the object definition. For example, there is a version attribute of an object. So if there is a conflict, you don't want that object to be missed. So you check that object through the code, verify the version, which one is needed to be kept. So based on the last version or the latest version, in comparison to time, it could be version based. It could be even based on the value of the object. For example, there is a database record and you have an object which represents that database, and that has a modified time. So that's not the update on the cache. It's an update on the database, but that update time happens to be part of that object. And if that object was added first and then another object overwrites it, you don't want that last update on the database to be lost, right? So if there is anything inside the object and you need to take a decision based on the attribute values, you need to implement the conflict resolution yourself for that. But like I said, most of the conflict resolution is going to be handled by default through our time-based default option. So whichever update comes last is going to be applied as the latest update on the item. And this only happens, remember that this conflict resolution logic would only come into play if there are two updates simultaneously added in the queue on the bridge, right? So bridge gets two updates at the same time. So which one to pick? Site 1 added or updated an item, and site 2 also added or updated the same item. So bridge now has to decide which one to keep in the cache or in the queue, and that's what gets replicated to site 1 and site 2 as well, because one has to win over other. So time-based conflict resolution is implemented by default, and that would get you through most of your cases. I hope that
Awesome.
answers. Yeah.
I leave it to you. Is there anything else that we're going over?
I think we're good as far as content is concerned.
Okay.
All the demonstration is completed.
All right, we're running right at the last minute here, so thank you to everybody that's come out. If you have any questions pertaining to this specific webinar, feel free to just email us at support@alachisoft.com. Definitely head over to our website and download a free 2-month trial of NCache Enterprise and use it in your environment. If you'd like help onboarding it, you can reach out to support@alachisoft.com. And if you have any more questions about if you want to buy NCache or to get licensing information, feel free to reach out to sales@alachisoft.com. We hope everyone stays safe and healthy. We look forward to seeing everyone again in our next webinar. Thank you very much, Ron, for a wonderful demonstration, and we'll see you all next time.
Thank you, Zach. Thank you, everybody.
All right.
Bye-bye.
All right. Bye.